Welcome to our introduction of the mole in chemistry. You may be wondering, why are we learning about odd-looking, ground-dwelling rodents? Or, unsightly skin perfections? Or maybe even double agents? Well, that's not what a mole is. In chemistry, a mole is just an amount of things. In fact, it is quite a large amount of things. It is 6.02 times 10 to the 23rd things, or 602 sextillion things. That's right, I said sex. But we don't teach you about the birds and the bees in chemistry. Anyway, everyone knows that chemists always do it with moles. If you're wondering who this good-looking fella is over here, that is Amedeo Avogadro. The number 6.02 times 10 to the 23rd is actually named after him. It's called Avogadro's number, even though he had very little to do with actually determining the value of that number. The value, if you're wondering where it comes from, is more of a physics thing than a chemistry thing, so I don't talk about it very much, but a little Google search will explain exactly where that number comes from and why it is what it is. But anyway, let's just apply it to some elements from the periodic table, like carbon, for example. So the atomic mass of carbon, remember, we can get that from the periodic table or from the atomic mass chart that was given to you. If you look up carbon on there, you will see it has an atomic mass of 12.0. Well, that is 12.0 grams of carbon in a mole of carbon. What that means is if you mass out 12 grams of carbon, you actually have 6.02 times 10 to the 23rd atoms of carbon. You have a number of atoms that you can associate with that mass. So if you were looking at silver, same story. You look up silver on your atomic mass table. The mass is 107.9 grams per mole. So if I were to mass out 107.9 grams of silver, I would have 6.02 times 10 to the 23rd atoms of silver. What about oxygen? This is a tricky one. Don't be fooled. Remember, in its elemental form, oxygen is a diatomic molecule, Hofbrinkel. Elemental oxygen is actually O2. So then we have to look at the oxygen's atomic mass on the table and double it. So oxygen's atomic mass is 16, but 2 times 16 gives us 32.0 grams of oxygen per mole of oxygen. So that means if we mass out 32 grams of oxygen gas, we would have 6.02 times 10 to the 23rd molecules of oxygen gas. But since there's 2 atoms of oxygen in each molecule of oxygen, we would have 12.04 times 10 to the 23rd atoms of oxygen. If you write this number correctly in scientific notation, it would actually be 1.20 times 10 to the 24th. Let's look at a couple compounds now. Let's look at an easy one like water, something we're familiar with. Well, to figure out the formula mass of water, you will need to look up the mass of hydrogen and the mass of oxygen on your periodic table or your atomic mass chart. You would see that hydrogen has a mass of 1.0. So if we have 2 of those, we have a total mass of 2.0 from hydrogen. Oxygen has a mass of 16.0. So adding those together would give us the formula mass of water, which is 18.0 grams per mole. So if I were to mass out 18 grams of water, I would have a mole of water. And if I have a mole of water, I have 6.02 times 10 to the 23rd molecules of water. Every water molecule is made up of 2 hydrogen atoms. So that means if I have a mole of water molecules, I have 2 moles of hydrogen atoms, or 12.04 times 10 to the 23rd hydrogen atoms, or 1.20 times 10 to the 24th, written correctly. There's 1 atom of oxygen for every molecule of water, so that means there's 1 mole of oxygen for every mole of water. So if I have a mole of water molecules, I also have a mole of oxygen atoms, 6.02 times 10 to the 23rd oxygen atoms. Let's look at silver nitrate. Silver nitrate is AgNO3. So if I were to look up those elements on my periodic table or atomic mass chart, silver has a mass of 107.9. Nitrogen has a mass of 14.0. And we have 3 oxygens, each with a mass of 16.0. So that gives us a total mass with oxygen of 48.0. If I add those up, I get the formula mass of silver nitrate, which is 169.9 grams per mole. So if I mass out 169.9 grams of silver nitrate, I will have a mole of silver nitrate, and therefore 6.02 times 10 to the 23rd molecules of silver nitrate. Every molecule of silver nitrate has one atom of silver. So if I have a mole of silver nitrate, I have 1 mole of silver atoms. So I have 6.02 times 10 to the 23rd silver atoms. Same goes for nitrogen. I would have 6.02 times 10 to the 23rd atoms of nitrogen, because there's 1 atom of nitrogen in each molecule of AgNO3. As far as oxygen goes, there are 3 atoms for every molecule of AgNO3, so I need 3 times 6.02 times 10 to the 23rd, which in the correct scientific notation would be 1.81 times 10 to the 24th atoms of oxygen.